be a chemical messenger of the endocrine system. Endocrine meaning inside. When I'm talking about inside my body, I'm talking about my cardiovascular system. They are also manufactured from triglycerides. So they are not an essential component of our diet. These also include cholesterol. So cholesterol is listed on our nutrition label. We still don't really know how much of our dietary cholesterol impacts the cholesterol in our human body. So it's a good thing to talk about that now, because you can see that they're not essential to eat for us to make. And so, it's going to have a huge genetic component, how your body makes and processes cholesterol or processes sterols. Everyone is a little bit different. And so, we really can't shame someone, if they have high cholesterol. Yes, there's things they can do maybe to their diet or to their lifestyle, but there are going to be components to that are outside of their control, unfortunately. So besides them being important to hormones, you can see here is a great example of how they are important to the cell membrane structure. Cholesterol kind of hangs out in between the phospholipids, and it provides that essential structure. Another important thing is that cholesterol is only going to be found in animal products. So when we're thinking about dietary cholesterol, we are thinking about animal products. If you eat something like palm oil, it's not going to contain cholesterol. But remember, it is going to contain the saturated fatty acids because it is solid at room temperature like butter. Okay, this is for your in-class activity. All right. So we talked about our fatty acids. We talked about our 3 major lipids. Now I just want you to think, why do we need to eat fats or lipids? We know that fats provide 9 calories per gram. And although everyone hates calories, that's really important, right? We need energy. Calories are an essential part of what our body needs to function. If we don't get enough, that is not good. So it's very energy dense, and that's a good thing. So if you look at something like a tablespoon of butter is going to be 100 calories versus about a whole loaf of bread, or a whole slice of bread is 100 calories. So it's very different when you look at the proportion. Fat is also used for energy storage. So it is stored in adipose tissue as triglycerides. So in a similar way, when we talked about carbohydrates, I asked you, okay, where is it stored? And you should say liver and muscles, right? As not glucose, but as our glycogen. It's going to be the same type of thing. I want you to know, where is lipid stored? It's stored inside of adipose tissue as triglycerides. And then it's also going to just supply our essential fatty acids. So if you think about, how our body needs those fatty acids to produce and balance out our inflammatory responses, you can see that here, right? So if you get cut, it is as simple as how your body responds with high blood pressure, with an increased blood flow of those white blood cells and those clotting agents, thrombin, prethrombin, all of those are going to be important. You cannot have that interaction happen in the human body if you do not have your essential fatty acids. So now let's look at adipose tissue. So adipose tissue is really interesting because as you grow and as you store more fat as triglycerides, not only does the number of adipose cells grow, but the length, the volume of them also grow. So they increase in number, but they also are going to stay there. So with fat loss, the size of the cell shrinks, but the number of the cells that have been created do not. So even if you, say you go through a period of time where you're gaining weight, and that's great, that's normal, and then you lose weight, your fat cells are still going to stay there. The adipose cells are still there. They're just not as big. So they really are like storage containers However, we used to think that they were a lot more passive, and now we know that not only do they secrete their own hormones that have a lot of feedback loops inside of our like vagus nerve, for example, like there's a communication there that we don't fully understand, but they are going to stay there in number. We also need to eat lipids because of our soluble vitamins. So people that are on low-fat diets, this was a really big concern because you need our fats to absorb. So remember, difference between digestion and absorption. We need fatty acids to absorb. So get those fatty acids and our fat-soluble vitamins into our bloodstream. We need to eat fat. So if you think about vitamins A, D, E, and K, if we don't eat fat with them, we're not going to absorb them. Lipids are also important for the cell membranes. So think about sterols, think about our phospholipids. They're also important to the protection of internal organs. So we have layers of fat around our organs that is normal. They need to be there. They're there for protection. If they're not there, that's not good. It's also important for insulation and body heat. So we talked about, what is the way that our body uses the greatest amount of energy. We talked about basic metabolic rate. All of that is essential. So if we are not insulated in an appropriate way, we are losing even more energy to our environment, which isn't good as well. And then also the creation of our steroid hormones, right? So yes, we can create phospholipids and steroid hormones. We don't eat them directly from our diet, but we do eat them, or the building blocks for them, we eat through triglycerides. So just know those. And then outside of just a health reason, why do we also need them, right? Why do we eat them if they're so, some of them are so unhealthy for us? So it's really just because of that texture and that flavor that is provided in foods. We, in the grocery store, a lot of the foods that are in the baked aisle section, they contain those trans fatty acids. You have to think, why would a manufacturer add it to those foods if they're so unhealthy? And it's because it maintains the texture. So you can bake something off, in Minnesota and then send it all the way to Arizona, and it's going to maintain that soft texture because of that trans fat. It's also the reason why ice cream is creamy. It's why French fries are crispy, and then why steak can get that really nice sizzle on it. It's all because of fats. It also is going to contribute to something called satiety. So fats are more energy dense, we know that, but they also take longer to digest. And so our body is able to take time to process it. That means there's more messaging in between our gut and our brain through the vagus nerve. So our body knows kind of what we eat. And if we eat fat, it takes a long time to digest, just like protein. A good example of this is why the volume diet doesn't work. If we eat a bunch of salad instead of eating something that is balanced with salad and fruits and carbs and protein, our body knows what we ate, right? It is secreting very specific chemicals to digest those things. So we can't just fill up on salad and be satiated. So let's also return back to how lipids are digested. So there are 3 different types of locations. Remember, we can remember the locations and the enzyme mechanism by the name. Again, Latin, right? So in the mouth, we have our mechanical digestion of fats through chewing, through the movement of our tongue, through the mixing of saliva. Specifically, the chemical that is going to break down lipids is going to be lingual lipase. So in the way that we have salivary amylase in the mouth, we have lingual lipase in the mouth. In the stomach, again, we have that mechanical action, the mixing, but we also have then gastric lipase that is going to be digesting the fats. And then the small intestine, we have our whole biliary system. So we have the emulsification of fats through the bile. We have enzymatic digestion through pancreatic lipase. So 3 different places lipase is digested. And then we have our micelles that help with absorption. So not only do we need the mixing of that bile to emulsify our fats, but we need to get them into a smaller, more easily absorbed little molecule. And we call these micelles, okay? So this before I go on, this is digestion. We're just talking about how it is broken down inside of our alimentary canal. Now we need to talk about how it is brought into our cardiovascular system, how it is absorbed. Then we're going to talk about how it is transported, and I'm going to go into cholesterol. So absorption, a lot of good stuff going on here. So we have our a large fat droplet that's been broken down, it's been mixed, and then we have bile that is coming in. Again, where is it? Where is it produced? The liver. Where is it stored? Right, our gallbladder. And so we get these emulsified little droplets. And the further they're emulsified, the second they can go into the walls of our intestines, we have micelles. So the micelle is the specific fat molecule that is going to go into our small intestine wall. And then, think about what they're actually made of. So inside of micelles, we have fatty acids, we have monoglycerides resulting from fat digestion, and now they're going into the epithelial cells. They're going to specifically go into the Golgi apparatus of our intestinal cells. And inside of there, we have our triglycerides through the action of lipase, right, are then going to break down the glycerol head into these individual fatty acids. So we're really getting them into their monomers. So we have the polymer, right, the triglyceride, and then we have the monomer, which is the glycerol head, and then our fatty acids. And they're going to be packaged, right? And then they form another type of molecule called a chylomicron. So there's the micelles, and then there's the chylomicron. Chylomicrons are then going to pop out of the epithelial cells and then enter the lacteal. So remember, the lacteal is a lymph capillary that is going to lead to our lymphatic system. We cannot and should not absorb fat directly into our cardiovascular system because think about what it does. We really need it to be processed in our liver and sent to where it is needed before we just want them to go right into our capillaries. Capillaries are very, very small. And so if we just put these kind of still very big molecules right in there, they would just clog them up. So we don't want that. Which is why, once it goes into our lacteal, it's going to be emptied out into our cardiovascular system into a major vessel and then processed in our liver. And I'll talk about that next. But, just in summary, before I move on from this picture, it's great. It can be really complicated. Again, it is the absorption of these fats. So they need to be kind of broken down into the micelles. They're going to be processed in the Golgi apparatus, kind of put back together into the chylomicrons. Once it's into a chylomicron, then it can be absorbed into the lacteal that is then going to transport it away from the intestine. So we talked about digestion. We talked about absorption. Now I'm going to talk about transport. So I love this picture as well. It's kind of similar, but you can see how it's breaking the fat molecule, the triglycerides, into its monomers, right? So we broke them down into the monoglycerides and the long chain fatty acids. We're going to put them back together as triglycerides. We can add some phospholipids, some cholesterol, some protein in there, and then bam, we get a chylomicron. So specifically, the types of chylomicrons have to do with how much phospholipids, cholesterols, and proteins we have in them. But I think really going through the different stages of this picture will also be helpful. So if I was a student in this class, I would draw the concept map of all the different types of fatty acids, all the different types of lipids, and then I would draw the absorption process because it is complicated. In order to get it through our cell wall, we have to break them all up. And then in the Golgi apparatus, we put them all back together again. And then we're going to package them into something even larger, our chylomicron. It's then going to enter our lymphatic system. And then we get our short chain and our medium chain fatty acids actually can go right into our cardiovascular system. So they're smaller. They're not going to block things in the same way like our big chylomicrons or triglycerides are. But these monomers that aren't recombined are going to enter in through our portal vein. So a larger vein. Okay. So what is the recommended intake? for all these things. We know that we need about 20 to 35% of our daily calories from lipids. Saturated fat, we really want to try to eat at least or less than 10% of our total calories. So that's total, not total from fat. And then trans fat, we really want it as low as possible, because think of it as it's like a super saturated fat, right? It's not just super solid, it's like really solid because it has that hydrogenation, but it also has that double bond. Then we have our polysaturated and our monounsaturated fats. We really want them to be 10% to 12% of our total calories. Think about, where we get them from. Okay. So this is where she should start on Thursday. I'm also going to go through it here. We talked about digestion, absorption. Now we're going to talk about our transport. And in order to talk about transport, we have to talk about cholesterol. So I'm going to go through this really quick. This is the chylomicron. This is what it looks like. This is where we ended it, right? We have our cholesterol, we have our phospholipids, we have our triglycerides, we have our proteins, all those things that were added back into that. The problem really is that lipids hate water, right? They're phobic, and the blood is watery. And so how do we get something that is hydrophobic into our cardiovascular system to be transported throughout our body? The solution is those lipoproteins. So they are arranged in a certain way inside of our phospholipid layer. So remember, the head of a phospholipid is going to be hydrophilic, so it likes water, and it kind of protects all the other things on the inside. And then our protein amounts are going to be kind of speckled all around there. Depending on what type of lipoprotein it is going to contribute to what percentage of phospholipids, proteins, triglycerides are inside of the chylomicron, or the lipoprotein, excuse me. So here's another great picture I love. You can see the triglycerides are really packaged inside of this phospholipid layer. The first lipoprotein I've already mentioned is called a chylomicron. It is produced by the cells lining the small intestine. It's going to transport something called our dietary triglycerides to the cells and the liver. There's also something called VLDL, or very low density lipoproteins. These are going to be formed in the liver, so it's not something we get from our diet. They're formed in the liver. And what's happening is they're taking our liver-made triglycerides to the cells and tissues. And then we have our LDL. So I've already mentioned that this is our bad cholesterol. There's really not bad or good cholesterol. It's basically just what they're doing and where they're moving our triglycerides from. So these are formed when VLDL deposits triglycerides. So you have the VLDL, you remove a triglyceride, and then you get an LDL. They are very highly concentrated in cholesterol, and they take cholesterol to the cells and the tissues. And then we have HDL, or high density lipoproteins. They are also formed in the liver, but they are going to remove cholesterol and transport it back to the liver. So the biggest difference here, the thing I want you to know, and the thing I'm going to talk about so much in the next couple minutes, is going to be LDL transports cholesterol from the liver to our cells. We don't always want them in our cells. We don't always need them in our cells. To get them there, we have to go through our cardiovascular system, and it can block, right? Because you're transporting cholesterol through them. It can block our vessels. So that's when we get something like atherosclerosis, arteriosclerosis. I'll talk about all what that is. Now, our HDL is going to take those deposits of cholesterol and it's going to put them back in the liver, which is where we want them. Because cholesterol is important, right? We need it to make hormones. We need it to maintain our cell membrane integrity. We need them. We just don't want too much of them. And unfortunately, the diet that we eat contains too much of them. And so we really want to see that HDL be effective at transporting them back. Now, transport is really affected by our heart rate and our blood pressure. And so, you know, if you think about how many people have hypertension or high blood pressure, has a lot to do with cholesterol, and a lot of times they correlate. So remember the four of these, very important. Chylomicron is kind of the starting one. Chylomicron is going to transport all the dietary cholesterol to our liver. The liver is then going to produce VLDL. VLDL is then going to take triglycerides and cholesterol to the cells and tissues. Once triglycerides drop off, then you get your LDL that is going to finish the transport of cholesterol to our cells that need them. And then HDL will bring them back. Oops. So you can see chylomicron is going to transport it to the liver. And then this picture is great as well. You can see the different amounts of our proteins, phospholipids, cholesterol, and triglycerides in each one of these lipoproteins. I would just note again, our HDL is going to be the highest amount of protein with it decreasing. Our chylomicron is going to have the highest amount of triglycerides. It's then going to form VLDL, which is going to drop off those triglycerides. Then you have primarily cholesterol, right? So you can see LDL, it's a lot of cholesterol. This is the same thing I mentioned, but it is done in a concept map. So you eat fats, oils, cholesterols from food, and then you absorb those triglycerides into the cells and tissues. And then what remains is going to go to the liver for dismantling. Then you're in the liver, right? So the chylomicron will transport it here. Then the liver is going to make a VLDL. It's going to send VLDL out. It's going to drop off triglycerides to more cells. Now the VLDL is mostly cholesterol, which means it's LDL. And then LDL is going to take the rest of the cholesterol to the tissues in the cells. All right, which sometimes we need, but we don't need it in too much of an amount. Then we get the cell engulf the entire LDL particle. Cholesterol is then going to be removed from LDL once it's inside of the cell. And then you have HDL, which is going around. It's going to clean up the cholesterol from arteries, dying cells, and it's going to bring it back to the liver. Because why would it do that? Well, we don't want to waste something like that. We also don't want it in the places where it's not working. And so if it's just sitting on the outside of a vessel, or I shouldn't say outside, it's like the inside wall of a vessel, it's just sitting there, it's going to gather and bind to any cholesterol that's going by, because, you know, like likes like, so it's going to bind, and it's going to create a blockage in that vessel. So we don't want that. We want a lot of HDL. So when we're looking at someone in the hospital, we want to see good cholesterol, so high amounts of HDL, and a low amount of LDL. Sometimes you'll see people just get really freaked out and they'll stop eating cholesterol and they'll stop eating fats, but we really need that HDL to be cleaning and doing what it does best. This is a different diagram of just what I talked about. I just love how this one shows how VLDL is dropping off those triglycerides and becoming LDL. So you can see that here. You can also see kind of the mechanism of the chylomicron. Remember, some of our short chain fatty acids can go directly into our cardiovascular system, but most of our triglycerides, again, that's a big molecule, have to be processed in chylomicrons and then transported through all of our different lipoproteins. So our lipoproteins are going to be bolded here. They're not cholesterol themselves. They are the transporters of cholesterol. So people will say like bad and good cholesterol, for example, I just said it, or, HDL is good cholesterol. Well, HDL really isn't cholesterol itself. It is a transporter for cholesterol. Let's talk now about how this specifically affects our health. because it's really confusing. I definitely suggest, being able to draw this picture. Drawing this is really great as well. I love just how this shows, more so how it's dropping off the different parts of the lipoprotein. So if you have elevated VLDLs, there is an increased risk for heart disease. This means that you are eating a lot of dietary cholesterol or triglycerides that need to be transported. So how do you increase this, and how do you decrease this? So we're really going to see this decrease when we have our omega-3s being eaten and through exercise. So exercise really helps our HDL get transported where it needs to go and pick up those deposits of cholesterols that shouldn't be along our vessels. Short chain fatty acids, excess added sugar, and a lot of calories are going to increase in our VLDLs. So those are things that we don't really want in excess. Elevated LDL is going to come from, an increase in those short chain fatty acids and then trans fats, especially. So if someone is eating a lot of fast food, a lot of like instantly baked things, they're going to have elevated LDLs. And then how is that going to be fixed? It's through all the things we talked about already, right? Soluble fiber. So, we talked about soluble fiber, how it functions in the gut, how it creates kind of like a jelly substance that is going to absorb dietary cholesterol so that it cannot pass and be absorbed into our body. So eating that is going to be great for our cholesterol. Eating lots of nuts and unsaturated fatty acids are going to reduce our LDL. The other important thing is that LDL is going to circulate until it's absorbed. If it's still circulating and it's not being absorbed by HDL because you're not eating the right things and your body cannot produce enough HDL, it's going to clog your arteries. So elevated HDLs, we call them good cholesterol. It's going to increase with omega-3s and exercise. Again, you're getting your heart pumping, which is really good. And then we actually see a decrease in HDL for trans fats with trans fats. So not only does trans fats elevate our LDL, but it lowers our HDL, which we don't like. So it decreases the risk of cardiovascular disease because of how they kind of go around and clean up cholesterol. So you can see here normal serum and then serum with someone with elevated triglycerides. There's just such a big difference in the actual molecules that are floating around in your blood. You really have a lot more cholesterol that is floating around that cannot be picked up and recycled and put back in the liver. When I talk about heart disease, there are a bunch of different types of heart disease or cardiovascular disease. It is the #1 cause of death for men and women. And then the type of fat in a diet can contribute to or protect from these illnesses. So, it's not going to be ever the cause of something. It is just going to contribute or protect. So there's, omega-3s or essential fatty acids that are going to be protective from these diseases. So when I say atherosclerosis, what we're seeing is a buildup of those fatty lipid deposits inside of our walls of our cardiovascular system. Okay, so we don't want that because it blocks our blood flow. We can also see this happen in the vessels in our brain, which can lead to a heart attack or stroke. So, it's so important that our blood pumps to where it needs to, that it's not being blocked or clogged. If it is, it can cause a brain bleed. It can cause a lot of inflammation. I'll talk about foam cells and how, an inflammatory response that is elevated is also not good. I think I showed this to you guys already, but this is the increase in heart disease death rates from 2017 to 2019. You can see that there are a lot of things happening in the South. I feel like they are just so impacted because of their cultural foods, because of lack of access to healthcare. Those things are also going to contribute to this. It's not just that person can control everything about their cholesterol. So atherosclerosis, more specifically, is the lining of arteries that incurs damage. So this can happen with smoking, infection, diabetes, hypertension, high cholesterol. They're all kind of related. And the more you have, the more they contribute to each other, and you kind of see this snowball effect. So really, the damaged arteries are going to create inflammation, which starts an immune response. So if you have blood going along here, you maybe then have some LDL, which is carrying a lot of cholesterol. And because of how cholesterol, the molecule is, and saturated fat, and just how they stack together, they're going to start building up on the walls here. However, if you have good HDL, it's just going to pick it back up again, right? And carry it to where it needs to be. But sometimes if you don't have that, the LDL becomes trapped in the blood vessel walls, and the body doesn't like that, right? So you get these free radicals that are then going to oxidize the LDL. So when we think about oxidants or antioxidants, antioxidants are going to fight against these. So free radicals are really just a name for like these like unstable molecules that go around and they just kind of rip things apart. Antioxidants can stabilize them. So the immune system is going to try to fix the oxidized LDL. So you have, LDL building up. You didn't have HDL to come through and clear it up. And so now you're going to have all the immune responses that you've learned about. So you have macrophages coming in from the immune cell system. And it's going to try to engulf the oxidized LDL, but it can't do it. It can't move it. That is not the mechanism of a macrophage. And so it's then going to become something called a foam cell, which is then going to initiate further immune response. So this specifically is called the scavenger pathway that is not the same as normal LDL absorption. So normal LDL absorption, is going to be a normal function. It happens with HDL, but the foam cell, right, from the macrophage, it just tried its best to clear that out. However, it's going to then cause even more issues, right? So you have the signaling of the macrophage. Now the foam cell is bringing more things in. You have the cells of the artery wall even proliferating to try to heal the damaged vessel, which then causes the hardening of the foam cell. And now you get a plaque. So when you think about like plaque in your artery or atherosclerosis, that's where it's coming from. It's actually coming from the hardening of those macrophages that are trying to engulf the LDL particles. It's really a fibrous coat that is going to keep all these things attached to the artery wall. So it's not only going to reduce the blood flow, but it can cause this to break off and then travel into smaller vessels that can completely block them. Some of them can go to the brain, which would be a stroke. It's really not good. So you can now see the atherosclerosis plaque building up. You also now see an embolism start forming. Really what that means is that you have this, the artery wall is going to spasm. There's a lot of high blood pressure, and then it causes the plaque to rupture and break free from the artery wall. So that's an embolism. The body is going to try to create a blood clot around the plaque, but it's not going to heal correctly. And then the blood clot can even create more blockage, which is going to contribute to the heart attack or stroke. This is a vessel with atherosclerosis. It's pretty hard to look at, I think. So just in summary, we know that diets high in saturated and trans fat are going to decrease the removal of LDLs from the blood, right? They can't be removed in a way that's great. Not only because, you don't have HDL, but the physical eating of those things are going to make it to where we cannot create HDL. It decreases our ability to do that. It's going to increase the triglyceride levels and total cholesterol in our body. It's going to contribute to the formation of plaques that can block arteries. And it really creates this whole snowball effect that is incredibly inflammatory, that impacts every system of your body. We discussed diabetes, and if we have a lot of glucose in the cell and it's sharp, and it does kind of a similar thing as well. This includes coconut oil. So please don't take spoonfuls of coconut oil. I wouldn't recommend that. Trans fatty acids are going to raise blood LDL levels as much as saturated fatty acids. It's going to lower the HDL levels. They're abundant in those partially hydrogenated vegetable oils, and we are not good at labeling them on food products. They should be reduced to the absolute minimum in the diet. So that is something that, you know, if there's a hard fast rule of nutrition and it's hard to find those, that's one of them, is to try to completely cut out our trans fatty acids. We know that there are certain things that are going to contribute to heart disease, and we can see them here, right? So there's some things we can't we can't change: our age, our sex, our heredity. Males in particular are more at risk than females. If why does the doctor ask you for your family history? They're trying to gather those factors that you can't control, that are outside of you. We also know that throughout, the process of us living, we don't get really great at processing things, right? And so the older we are, the more at risk we're going to be for these things. Things that are going to contribute is smoking, high blood pressure. I would also like to say that this also includes vaping. This also includes smoking like marijuana. It's smoke. There should not be smoke inside of our lungs. High cholesterol is going to impact this, right? So if we're eating high foods that are very high in cholesterol, we don't know right now to the extent that this has. Inactivity, right? So think about how important activity, getting our blood pressure up, and our heart rate up, is going to help us with this. Excess body fat, and I'm talking about the visceral fat, not the subcutaneous fat, that is so important for us to an extent. And then diabetes specifically because you have the same foam cell formation from the macrophage, but instead of it being created through like an atherosclerotic plaque, you have it being caused through nicks in the vessels. To reduce risk, just do things in moderation, right? We want to try to focus on our unsaturated fats. We want to maintain consistent fat intake that is at a moderative level in between 20 and 35%. We want to limit saturated and trans fats, and we want to get an adequate amount of omega-3s. That is so, so important. And so consider including fish in your diet. Fish is very expensive, but you can get fish from like canned form, so tuna, sardines. You do want to look out for the added salt in those foods and get the ones that aren't in oil or aren't in salt water. We want to try to eat more whole grains because of that soluble fiber that is going to contribute to keeping cholesterol inside of our digestive system so it's not absorbed. We want to also just get our blood lipids checked. We want to see a doctor once a year if we can, and know where we're at. We want to be active. We want to maintain a healthy weight. And again, I wouldn't say it's too much about weight, but just being aware of, having a consistent weight is really important. We don't want to gain too much or lose too much weight over a certain period of time. It doesn't matter, how fast you lose weight. We really want to not lose it too quickly because it'll change our metabolism. It'll cause our body to want to hold on to these things because they can be used for energy. And so why would our body, if we are starving it, just get rid of it? It's going to change. Our body is very adaptive. And then we also want to avoid tobacco. So first and second hand, this includes vaping, this includes marijuana. So smoke, right? We do not want it there. In our lungs, it causes inflammation. All right, so now I want to just go ahead and pop over to our discussion board post. This is the first time we have done a discussion board where I'm asking you to actually look for an article. So just keep that in mind, is that it is going to take you a second. It always is going to take a second when we are researching, because I'm expecting you to read peer-reviewed articles. So you can go ahead and click over to your discussion board post. Again, this is 2. It is due on the 5th. And it's due by midnight. So the replies must be made on 2 separate days. So you can make your initial post and then a reply, and then we're just having you return so that, you know, people aren't waiting until the last day to make their initial post and then you can't get the replies. So really you need to have it done on Saturday night. So please keep that in mind. I'm asking you to go to the Klein Library or Google Scholar, find authentic research to answer these questions. And then I have 2 different questions for you. I care about you guys researching things that you're interested in. So if you're like, hey, like I'm really interested in like cholesterol and autism, that's awesome. You should explore your interests for your class. Just please email me and CC the TA. So when we're grading, I'm not going to like, take off points because you didn't answer one of these questions. You kind of found your own. Okay. Communication is so important. Please tell me ahead of time. So in order to receive full credit, your initial post must be at least 300 words. Now that doesn't seem like a lot, but I'm requiring you to look at the research and provide references and citations. So you're doing that, and then you're also doing 2 replies to classmates. The replies also include citations and references. It can be based off of, the article that they made, or you can find a countering article depending on your search criteria, but I need to know who you're citing. You can cite me, you can cite the textbook, all of that is fine, but you can't just say something without backing it up. I do want you to have at least 3 of these. So if you check the database here, you can search for specific criteria. There are no direct quotes permitted. So before, and I've done this, is I can kind of tell the wording that you use that if it's just copied. And so I will just highlight it. I will go to the article, I'll control find, and I will find where you just plagiarized that sentence. So please don't do that. We can tell. Just summarize what you read. Reading the abstract is really important. And then I would also always read the first paragraph of the discussion of an article. Those are going to be where the most important findings are. I do want you to go through an entire article, but you need to read at least those 2 things in order to understand what the article is talking about. These are your 2 options. You can either look at high fat and high protein diets. It asks you, what is the evidence, if any, of benefit for the average adult consuming high fat, such as keto, or high protein, such as paleo diets? Can you choose to look at one type or both? I want you to evaluate the impact on weight, on labs, all those things that are actually important, right? Me taking a dietary recall of someone is not going to help me. I want to see how it's impacting their actual physiology. And then, or you could research type 1 and type 2 diabetes. So what are the main differences between type 1 and type 2 for both types? What are the primary health consequences if not treated properly? This one I would say is a little bit more straightforward. So if you kind of want to, discover more about, I would say I would look at a specific population. So if you're looking at children that maybe are diagnosed with type 1 diabetes late, what does that mean for them? Because if you just search this, it's going to pull a lot of articles. So the way that you're searching in that Klein Library search tab is going to be really important. Okay, I think that is about it. I will go ahead and post this. Also keep in mind that I do not answer my email through BB Learn. I answer it through my email address that is in the syllabus. If you have any questions, go ahead and email me ahead of time and I will get back to you. Awesome.